First, I'd like to thank Gabby for lending me his laptop so I can actually do this presentation. That is what happens when you buy the latest MacBook and just expect everything to work. Thank you for the team down there to trying to help me sort that out. Anyways, my name is Thomas Watson. You can follow me on Twitter and ask me questions there. So if there's something that is kind of weird when I talk about it today and you don't get a chance to ask a question, you can hook me up there. Also, I'm on GitHub where I do a lot of open source stuff. So check that out and contribute, of course. So the open source stuff I do is mainly Node, by the way. How many of you use Node.js? Fewer than I had hoped. There's some really exciting hands down there. Woo! Okay, that's good. So I work for this company called Upbeat. And what we do is we instrument JavaScript, both in the front end and the back end, and figure out what goes on in a live production application. And the thing I do at Upbeat is I'm responsible for the Node stack. So everything we do with Node, that's basically me running that. And that means that when you do npm install Upbeat, you are running the agent that I'm writing and I'm maintaining. So I'm not going to talk about Upbeat, but I want to mention that Jack said something earlier in 2 talks ago about Elm and about there was a question from the audience like, what is can you use Elm in like really like critical applications? And I was thinking, can you use Node in really critical applications? I was like, what is the most critical application I could think of? It's like something to do with space, of course. So it's really cool that NASA is actually using Node inside the new spacesuit they're developing. Or I don't know if it's cool or if it's frightening, but it's cool in a certain way. By the way, does anybody get some weird Pixar references when they're looking at this picture here? It's a pretty cool spacesuit. Okay, my talk is on GitHub, so all the slides is there, and you'll be able to also find a lot of the code that I'm going to show you. So don't worry, you don't have to understand and read all the code on the slide if you can't see it. It's going to be it's actually already on GitHub, so if you're sitting in the back, you can follow along there. Also, I'm going to inject some pictures of cats when there is like really heavy code, which means that then you can just like zone out and think about the cat. And okay, so without further ado, my talk is called Instrumenting Node.js in Production. And what does that mean? So what does instrumenting mean? What is it that we want to achieve? Well, usually you deal with HTTP requests in production. When I'm talking Node, your JavaScript thing or the browser is talking to the either API or the web, the Express app or something, sending requests to it, and you want to measure what goes on inside your production application so you can figure out a way to optimize the speed of the application, of course. So we call these transactions. So we want to measure these transactions. And when you have a request going into the application, it might talk to the database or it might render a template, and you can draw these things on some kind of timeline. And each of these we want to measure how each of these specific action that goes on during the request, how long they take. So we call these traces, and it's basically just a simple point A to point B. How long did that take? But something that is really, really interesting and really hard to do in Node is when this happens at some point, you get like a weird stack trace. You know that in JavaScript that everything is asynchronous, and you can only go back to the latest asynchronous boundary. But it would be really nice if we kind of out of the box could also figure out what request actually caused that error to happen. So all of this, to do that, the normal solutions for that, the normal solution, is to use some kind of global or singleton object to store the context, aka the active request. But being Node or JavaScript, or at least Node in general, they can be 100 requests going on at the same time. So you can't just have one global object or singleton thing to store the request, because which one is it? There's 100 going on at the same time. So we can't really do that. So people sometimes resort to is to simply pass the context around in the app. But that is not really that user-friendly, and it's really like ugly. And you have to change an existing application to do that. We don't want to do that. So what then? What is the solution to this? So to find the solution, we have to look at the problem, and the problem is the Node.js event loop. Or this is the Node.js event loop. So Node is synchronous. So how can it deal with all these 100 or even thousands of requests at the same time in one process? So the way it does it is it's using the event loop, and basically all the yellow stuff there is bits of code that is running, and all the blue stuff is just waiting around doing nothing. And the reason why it's waiting around is because it's waiting for the database to respond with the stuff you asked it for, or the file system to respond, or the network to respond. So it's just waiting. And then when it's done waiting, it calls the next bit of synchronous code. So everything in Node is always synchronous, and only one piece of synchronous code can run at the same time. And we can use that to our leverage. We can leverage that to our benefit. So if there's more than one request, that request will just get stuffed in between in the free space while it's waiting for the database for the first request, etc. So, and we'll see later how we can leverage that. So the goals that we have is we want to, of course, track the HTTP requests that's coming in as transactions. We want to instrument the I/O, because let's face it, the I/O is where we spend most of our time waiting. That is your database request, your file request, etc. We could also talk about maybe there's some synchronous stuff that we want to make traces of. It could be like a really nasty regular expression, or JSON parse can be really, really ugly if you give it a really, really huge JSON document. That's a nasty attack vector if you don't validate the length of the JSON that your client is sending. If I send you like a 100 megabyte JSON document and you try to just parse it to JSON parse, I'll basically dash your server really, really easily. So maybe that would be interesting as well. And then we want to associate exceptions that happen in your application with these transactions, as I said. And we don't want to do it with the stuff about manually passing around the context, because that's just not really plug and play. And of course, we want this to happen with absolutely or as tiny as overhead as we can think of, right? So it doesn't affect the performance of our application. That would be a really bad tool that we install to measure the performance, and it affects the performance. So the problems, as I said, is the multiple active HTTP requests, not being possible to associate an exception with the origin HTTP request. And then the last thing is actually the key here. There's no API to pass the context across the async boundary. So what do I mean by the async boundary? So every time we, for example, make a HTTP request, a database request, open a TCP socket, we used to give a node a callback, and we know that it will call this callback whenever the thing is done. So what happens when we give it a callback? So the callback is actually being queued on the event loop, and at some point in the future, when the thing you asked it to do has finished, that callback is going to be dequeued from the event loop and be called. And it would be really, really nice if we could kind of bridge that gap, so we know that, okay, this callback that was queued on the event loop was actually running in this context. It was because of this HTTP request that we queued it in the first place. So when we dequeue it, we now have the context back again. So if we tackle that, we solve everything. We solve the two first. So as I said, the solution is to record the context when a callback is queued, and to restore it when the callback is dequeued. And for example, that means that then we can use this global property all of a sudden. So now we can have a global or a singleton thing that just call it current transaction, and we just when a new request comes in, we seed it with the request, so it always knows what request is is active. And then we simply just record the context, record the current transaction when we add a stack trace, a callback, to the queue, and even if it gets overridden while we're waiting for the callback to be executed, then when the callback is being prepared to be executed, we just restore whatever it was. So how do we do that? I mean, this is awesome, right? Like everybody wants this, but how do we do it? The solution, do you guys know what this is? This is a monkey patch. So we need to patch the shit out of Node core to make this work. So if you start from the beginning, we need to patch module._load, and module._load is basically the magic that goes on behind the require function. So every time you call the require function, inside Node core, there's a function called _load. On the module, there is such a thing. And we should patch that to, let's say, it would be really nice to know every time a new HTTP request comes in, because then we have the option to kind of like start this transaction. So if we patch, so we want to make sure that every time somebody requires the HTTP module, we want to make sure that instead of returning the actual HTTP module from the require function, we return a slightly modified version of the HTTP module with our little bit of tracing logic built in. So that's one thing we need to do. We also need to, and to make that really easy, I wrote a module which I have a tendency to do a lot, called require in the middle, which is kind of like a man-in-the-middle attack for the require function. So you can just say, I want to hook into these 3 modules, and then it will call a callback. You specify every time one of those is being tried to, when Node tries to require them. And it uses the cache in Node, so it will only happen the first time you try to require it, so it's really nice. So if we go back to the second point, we want to also patch the HTTP server to access the request, as I said, using the require in the middle module, for example, or do it yourself. And then finally, we want to patch every async operation in Node. And this can sound quite daunting, and it kind of is. But let's start like listing what are the async operations that can actually happen to kind of make it a little bit easier to comprehend. So we have the timers. You all know that. That is your set timeout, your set interval, your set immediate. Then in Node, of course, we needed to invent something for ourselves. So we have the process.next tick as well. So we need to patch that also. And then thanks to TC39, we now also have native promises in Node. And those can also do asynchronous stuff. So we need to patch native promises, which is a bitch. Excuse my French. And then we need to patch something called libuv. And for those of you who don't know what libuv is, it's okay because it's usually not something you have to deal with. But libuv is actually the C code that lies beneath the JavaScript code in Node. So Node is part JavaScript and part C. And that is all the stuff that does the I/O for you. So every time you make a HTTP request or read something from the write to the file system, libuv is invoked because JavaScript in itself don't know anything about I/O, about doing I/O, because it was built to run in a sandbox environment in the browser. So there's nothing in the JavaScript standard library to do I/O. So that is why we had to build that ourselves in Node, and that is called libuv, and that is written in C. So all that stuff is, of course, also doing asynchronous things. So we do have to patch that. But luckily, we don't have to patch the C code because there's a binding layer between your userland code and the C code inside Node. And we just patch the binding layer in JavaScript, and then we're golden. So that is basically how every application performance monitoring product out there works today in Node. So that being the company I work for, Upbeat, or New Relic does it the same way. Basically go in and monkey patch everything in Node. And of course, we need a lot of tests and stuff like that, and it's like a lot of work. So it would be nice if there was actually an API for this. So when I'm not working at Upbeat and I'm not doing all my open source stuff, I actually am on the Node.js Tracing Working Group, There's a lot of working groups under the Node.js Foundation, and this is the working group where we are talking about how do we make tracing easier in Node. And Trevor Norris, who is also on the working group, he have been working for a long time of this awesome thing called async wrap. And async wrap is actually this missing API that makes this a lot easier. So, and you can go to GitHub under the Node.js organization, and there is a tracing-vg repo, which is where we do all our stuff, and there is documentation, and you can see the meetings that we are having. So, what is this async wrap? So, what if I told you that async wrap actually ships with Node since version 4? You didn't know that. Maybe because over half of you don't use Node, but that's besides the point. But it's not ready yet. It's not ready for production, but the C code ships. So all the stuff inside libuv, that ships, but there is no module. You can't require async wrap. So we have to do it the way that Node itself binds to C. We have to use the process.binding, and you can actually bind to any C code that you have, and we're binding to the async_wrap module, and we get back a JavaScript object. And we can do stuff with this JavaScript object. So one of the things we can do is we can set up some hooks. So there's 4 hooks: init, pre, post, and destroy. And then you have to enable it to actually run. And then of course, you have to define the hooks as well. So the init hook is being called every time you queue a callback on the event loop. So then you get a hook into knowing when that happens and what is being queued. The pre-hook is then called later when just like the tick before, or not even the tick before, but the moment before the callback is actually being run. The pre-hook is called. Then remember, everything is synchronous in Node. If something asynchronous happens, we are queuing. So when the callback is finished running, we're done with the synchronous part of this particular operation. And then the post hook is called in the same synchronous flow. And then at some point later, when this thing is garbage collected, the destroy hook is called. So let's try to use this. Let's say we just like get a file descriptor by opening a file, or getting just before I call fsopen, I just log before, and after I call fsopen, I log after, and then inside the callback to fsopen, I log done. And if you try to run this code, what will happen? So first, we will see that user before it's called, even though all the other stuff been set up before, but the first actual log entry that is being logged out is user before. Then the init hook is fired, so we can see it logs async wrap :init. And then the after, because we haven't run anything yet, we only like added this to the queue, but we haven't actually started doing anything. And then at some point later, whenever it got the file descriptor from the file system, we get the pre-hook, and then the callback is called, so we see the user done, and then the post hook, and then finally the destroy hook. So what is this log thing, you say? It's something that I made up. Let's try to write console log instead and see what happens. And we get this nice error message, fatal error and Node crashes. So the reason for this is, many people probably don't know this, but console log is actually asynchronous by nature. It's doing asynchronous stuff behind the scenes. So what happens when we do asynchronous stuff and we have async wrap? Well, of course, the init hook is going to be fired. And if we are then doing asynchronous stuff inside the init hook, we have an infinite loop. So that's not really nice. So it makes this really, really hard to debug if you can't use console log. So what do you do instead? So you could use the FS module in Node, which have a write sync method, which, as the name implies, is synchronous. And usually you give it a file descriptor as the first argument, and there's like 2 magic file descriptors in Node, the integer 1 and the integer 2, which is standard out and standard error. But it's just a stream of bytes. So if you want to use the nice stuff we're used to in console log with the formatting parameters and the trailing line break and stuff, we have to use util.format, which is also a Node thing. So that can be really hard to write those debug statements. So what I like to do instead is I like to use the secret method that also ships with Node, which is called _raw debug, which is basically a synchronous version of console log. So yeah. And if we try to use process._raw debug, hey, we're back to a working example. Cool. So what is this init hook thing? It gets 4 parameters, a UID, and that's basically just an incrementing number. So every time you queue a callback on the event loop, that incrementing number will be incremented. Starts at 1 and just goes up as long as your process is running. Actually, I don't know what happens if you run your process so long, so you get an overflow. That would be interesting. So, and then you have you have the this property is actually set to the current handle, and you can use the handle for some interesting stuff that I'll show in a second, and also tell you what the handle is. Then you get the provider. The provider is also an integer between 0 and 23 at the moment. This might change, and it basically tells you who is actually queuing the callback, which can be really nice to know. And if you run it in this in the console, you can get, if you try to bind to async wrap, you can access the .providers property. And you can see all the providers that we currently have. So for example, if you wanted to do something just with timers, for example, you didn't care about anything else, you just wanted to do something with timers, you could check if provider was the value 17 or providers.timer wrap, which is probably a little bit easier in case they change the number, which you do sometimes. And then you have the parent UID and the parent handle, which I'll also get back to. But basically, sometimes you can have like one callback, one handle wanting to invoke another handle, so you can have this parent-child relationship. But normally, these are null. But when you're doing TCP connections, there will be a difference between the socket being created and the connection being handled, and that's like 2 different callbacks. So what are these handle objects? So normally you write your stuff in JavaScript, as I said. So you have your usual line code that talks to the Node core, which is also JavaScript, and then it either talks to V8, which is C++, or it talks to DWB, which was the C part. So how does it communicate between the JavaScript code and the C code? How do you transfer data across this boundary? For example, let's say you want to make a TCP connection to a port and an IP address. Like, how do you tell the C code, like, what is the IP address and the port that I want to connect to? This is where handle objects come in. They are like the vehicles that we use to transfer data back and forth. So this is actually from the net connect method, slightly modified to fit on the slide. So you can see that it uses a process.binding to get the TCP wrap thing, and then it gets 2 handles: TCP connect wrap and TCP. So these are the handle objects. We make instances of those handle objects, and then we add properties to it. So for example, we have the address and the port are being added to the request, the TCP connect wrap handle object. We can also call functions in them, as is done with the TCP handle object. And so these rec and socket are actually you at this. So that means that from inside the init function now, and all the other functions for that matter, all the other hook functions, you now have access to, for example, the address and the port of the connect wrap handle. So that is all fine. And the final thing, when you have the different hooks being called, how do you know that it's the same callback in each of the hooks? That is, of course, the UID. I hope that makes sense. So you can reference the same UID in each will be the same callback. So a little thing about timers. So we all used to the set timeout. Here we have 2 timers, 2 seconds each. So if we imagine we are using the async hook thing, what will happen though? So first we will expect that we'll print out before 1. Then we will expect the init wrap, the init wrap, this async wrap init thing to be printed out, because we are of course queuing the callback for the set timeout. And since 2 seconds hasn't passed yet, we're jumping down to after 1, and then before 2, and then we're queuing another another callback, but we don't get a call to the init hook. We just go directly to after two. And then when the 2 seconds has passed, we get the pre-hook, of course, as we expect, but then we get the 2 callbacks just after each other, and then a single post hook and a single destroy hook. So why is this? It turns out that JavaScript tries to be really smart about this, or V8, and share the handle objects between the timers with the same values, in this case 2000 milliseconds. So if we want to be notified upon each and every set timeout, we still have to do it kind of the old-fashioned way with monkey patching, set timeout, etc. So how are you guys feeling? This is how you started the talk, hopefully, I hope. Like, yeah, this is going to be exciting. And then you're like, what? So I put in these because now I'm getting to this slide. So we will go back and see this one again. So just internalize that as I go forward. And remember, of course, that all my slides and the code that I'm about to show you is on GitHub. So so let's see if we can. Is it okay if I unmirror the screen? I'll hope that that's not going to be an issue here. So because otherwise I can't see what I'm doing. So, and we're gonna make this bigger, and we're gonna make this bigger. Okay, how are you guys with this? Is that okay? Okay, so I have a simple HTTP server here. It has 2 routes that I've added, get posts and get posts / some ID. And I'm just using a simple padding matching thing to match like the URL that's coming in. And if there's no match, I'm going to return 404. And if there's a match, I'm going to take the route function and I'm going to actually call it with the request and response so I can return some data. And then I'm listening on port 3000. So maybe, okay. So if you try to run this, okay. Whoa, we're missing the entire left side of the screen there. Well, maybe I can just do like this, and then like this. So, yeah. I'm not used to this keyboard, so excuse me while I try to type. Okay. Oops. There we go. This is better. So, if I try to send a request to this, so we're using good old curl here, local host. OST in Danish is actually cheese, so it's like local cheese. And P cheese. So it's just printing out. Oh, I didn't. It was a 400. It was posts in plural. And we got some data. There was not like a Mongo database running on this one, so I had to I'm actually connecting to the cloud somewhere in the United States, so it takes a little while to do this. And of course, we can also take a specific post here. Oops, forgot the slash. And we get that specific post. And you see on the left side, it just prints out all the paths that we're hitting. There we go. That was not the. Oh. Shit! I opened this in a. how do I switch to another? Gabby, how do I switch to another to another desktop? I can't use the three-finger thing. Well, screw that. I'm just gonna open this again. Oh, there we go. So I baked this one earlier. The only difference here now is I'm requiring my new stats module that I wrote in the beginning, and it's really important to do this in the beginning because otherwise it's not going to get a chance to hook into the require function of all the other stuff and monkey patch it. And then the only other thing I'm doing is, this is of course something you want to do like automatically, but I'm just manually creating a new transaction here, and I'm then hooking onto the finish event in Node and setting the status code. So I know in the transaction if this was like a good transaction or a bad transaction, if it was 500 or whatever, and then I'm just ending the transaction, so basically just stopping the timer. So that's basically the only difference. So if we try to run this instead, oh, and now it's actually if we started with async, I have this little nice thing here, async grab 1, using async grab, there we go. Because the code base, I'm not going to show this, but the code base, if you are interested in looking it up on GitHub, is also containing a version of how you would do this without using async grab. So basically how Upbeat and New Relic is doing it at the moment. But we're just going to see the async grab thing here. And I now have to get back to this. And if we actually just, before we run this, go in and look at what is actually going on inside the stats module that I wrote. So the first thing I'm doing is I'm actually hooking into the module ._load function to make sure that we, for example, when we require the MongoDB driver, we get a chance to hook in and see, because what we want to achieve here is we want to like measure how long does these Mongo queries take that fetch the data. So how does that look? This is really, really simple. I'm using the require in the middle module to basically, and then I'm giving it just an array of modules that I want to hook it into. You could have given it HTTP and HTTPS here as well. And then I'm basically just calling the hook with the array of modules, and then it's calling this callback whenever one of the modules that is in the array is being required. And then I basically made a modules folder here where I have like each of the module that I want to. Oh, you can't see that. Well, so I have like one for MongoDB core, and I have one for Postgres. And they're basically just going in and trying to patch. You can see here that we're patching the Postgres client. We're trying to patch the native client if that's installed, etc. So after we patch that, then we basically, if we're using async grab, we are first calling the async hook file, because there's still some things inside that. There's all this stuff we want to monkey patch that we can't like use async grab for yet, because things are changing, hopefully soon. And then there's the actual async grab thing. And as you can see, I'm using the process.binding to get at it. And then I'm just making a note of the provider ID for timers, because as you remember, timers were a little bit weird, so we don't want to do this for the timers. We want to patch them manually, because otherwise we can only get like one hook for each type of timer there is. And so we have all the hooks down here, and you can see in the init hook, for example, we check, okay, if the provider is equal to timer, then we just like don't do anything. We expect like to have monkey patch that in one of the other files. And then we just have these two maps where we keep track of the value of whatever current transaction is when we queue it. So we have the init state map, and we just use the UID as our key, and then we know what was the current transaction whenever this callback was queued. And then we have the pre-hook down here, where we say, okay, let's just, because the current transaction property might have changed in the meantime, so we just like keep a reference so we don't override it. Okay, what was it just before we are calling the callback, and then we just override it with whatever is in the init state, and then in the post, we just set it back to whatever is in the previous state map. So pretty simple way to juggle like this current transaction property and make sure that it's always, every time you're running a piece of synchronous code, is always whatever set to whatever was the current transaction when that code was queued. So now let's try to run this. Boom. So if we try to get at the posts here, all the entire array, we just have to get to United States there. So now you can see the output. If I zoom in here. So the output here is a little bit different. Now we also get the status code because we recorded that in a transaction. And I'm showing that it took 2,000 milliseconds. And then there's like a list of a lot of dB things. And that's basically because right now, just to make this really, really simple, I'm just writing out like all the traces that were activated. And there's a lot of calls to the dB, apparently. 1, 2, 3, 4, 5, 6, 7, something. And you can see each of the trace, like how big of a percentage of the total time did that trace take. And it doesn't necessarily add up to 100 because there is stuff that we don't trace. This is only the database stuff. So if we try to run the same thing again, you notice now there's only one. It's like the same command that we ran before, but now there's only one dB trace. And that's because Mongo is like lazily initializing the pool of connections. So the first time it's like, oh, he wants to talk to the Mongo database. Let's like initialize all these like pools, or this pool with like 10 connections in it, and make sure that everything is operational. And then when we do the second post, get/post, we just use one of these connections, and it's a single query. So already here we can see that. That's pretty cool. And if we try to get a specific post, we can now see that because we are using the name of the route instead of the URL to name these transactions. To name these. There we go. We use the name of the route to name the transactions. Then we can actually get this generic name. So no matter if we call like we have different IDs in the URL, we can all like use this name as a grouping mechanism to get like all requests to the specific endpoint group together and measure figure out like why are some slower than the others, and maybe it's because the query was different or something like that. So that's really, really neat. So, okay. How many of you guys are thinking of cats now? It's good. So I'm going to wrap up, no pun intended, which just going over a few gotchas if you want to use async wrap. Besides the fact that it's not production ready yet, but it's getting there. So with the handle creation time, so that's actually when the init function the init hook is called. It can be a little bit weird to figure out sometimes. For example, when you create a new HTTP server, it's not gonna, you actually give it a callback, but it's not calling the init hook right there. It's waiting until you call the listen function. So console log, as I talked about, you have to be careful about putting those in your hooks. Process next tick is currently not supported by async wrap, so you have to patch that manually. There was the issue with the timers that I talked about. Then there is promises, which is not covered by async wrap yet. It's also something that hopefully will make it to the final release. And then there's the problem of having multiple async wraps. So if you have like two set of hooks that you've tried to set up and expect both of them to be called, that's not going to happen at the moment. Right now, the last one to be enabled is going to be the one that is going to be called. And then there is 1 month of my life in that slide. So apparently a lot of database drivers have this tendency to, instead of using the normal event loop to store callbacks, they have their own little queuing system because they have a pool of connections, and if you are opening the 11th connection, if you have 10 connections in the pool, what is this going to do with this callback you just gave it? It can't like try to execute the request to the database yet, so it will have this little pool, this little queue that it tries to maintain itself, and as we saw before, that pool is being initialized on the first request to the application. So that pool will now queue thing will now run in the scope of this first request. So every time the callback is then being called, it thinks, oh, I'm now being called because of the first request, which is not true. So you have to patch those queues manually, which is really irritating, but that's just the state of how things work. Also, there's this thing, ES6 modules. So they are ES6 modules, as you probably know, whenever that gets to Node, are immutable. And because they're immutable, it means that we can't like do this magic thing where we just, oh, let's monkey patch the HTTP module before we return it from the require function. So yeah, we don't know yet how we're going to fix that. But it's something that a lot of smart people are working on. It's something that has the attention of both Google and the Node.js Tracing Working Group and a lot of other smart people. So I can't give you the answer to that, but we'll see. Finally, go to the Node.js /tracing-wg repo on GitHub. You'll see all the stuff we're doing in the tracing working group. There is even all the documentation for async grab is there. So, and it's being kept up to date. And speaking of that, right now, if you're using Node 4, there's kind of like one version of async grab, and if you're using Node 5, there's another, and if you're using Node 6, there's a third, and it's basically just based on whatever is the latest code that are being compiled when we're releasing a version. And then there was like issue number 29 on that side. It will have an overview of the state of async grab, so you can go in and then see like, oh, did they fix the promises thing yet, or stuff like that. So that's a nice issue to keep track of if you're interested. My slides and code are on the GitHub as well, and I don't know.